Most Bitcoin sits idle because using it in DeFi usually forces a compromise. The standard route is to hand BTC to a custodian or convert it into a wrapped asset on another chain. Trustless Bitcoin Vaults take a different approach. Native BTC is locked directly on the Bitcoin network under predefined spending conditions. A corresponding record is created on Ethereum that integrated applications can use as collateral. The protocol is chain agnostic and can support multiple applications per chain. The first deployment is on Ethereum, with Aave v4 as the first integrated application, enabling native Bitcoin-backed borrowing. Let's unpack how to create a vault for the first integration application on Aave v4. To create a vault, a depositor selects which application to use, decides how to split their BTC across one or more vaults, and locks the BTC into taproot scripts on Bitcoin. Off-chain, the depositor coordinates with protocol actors, a vault provider who manages claims and challenges on their behalf, and vault keepers who provide security backstops to pre-sign a transaction graph governing how the vault can be spent. Once setup is complete and confirmed on-chain, the vault activates on Ethereum, and the BTC is supplied as collateral into the depositor's position. What is the borrowing flow? With an active vault position, the depositor borrows any ERC20 loan asset supported in the Babylon Core spoke on Aave v4 against their BTC collateral. Repayment works the same as any Aave position. Repay the debt to free up collateral. How does redemption work? The depositor can withdraw any vault at any time as long as the remaining position stays sufficiently collateralized. On Ethereum, the vaults are released and a redemption event is emitted. The vault provider uses this event to generate a zero-knowledge proof and broadcasts a claim transaction on Bitcoin. A challenge period follows, during which other vault keepers can dispute invalid claims. Once the challenge period passes without a valid dispute, the native BTC is returned to the depositor's Bitcoin wallet. If the vault provider is unresponsive, the depositor can redeem independently using their own credentials and artifacts. How is the position monitored on Aave v4? On Aave v4, risk is managed through a metric called a health factor. Health factor combines collateral value, debt, and protocol risk parameters to assess the health of the position. As BTC price falls or debt increases, health factor falls. If it drops below 1.0, the position becomes liquidatable. If the position is liquidated, the application will reset the health position back up to the target health factor. How does liquidation work? If the BTC price drops and the health factor falls below 1.0, the position becomes liquidatable. Permissionless liquidators can liquidate the position by repaying the debt. In return, they receive one or more vaults to cover the collateral they are owed. Since vaults are indivisible UTXOs, the liquidator can only seize whole vaults. If the sum of seized vaults exceeds the owed collateral plus the liquidation bonus, the protocol requires the liquidator to repay the difference, either as additional debt repayment or, if the debt is fully cleared, as a WBTC fairness payment to the depositor. Seized vaults are either redeemed directly on Bitcoin by an arbitrageur, or the liquidator receives WBTC through one of the registered liquidation liquidity providers, and an arbitrageur later redeems the underlying BTC. How does split vault liquidation work? BTC vaults are indivisible UTXOs. A vault cannot be partially seized. To allow depositors a de-risk option, TBV supports a split vault mechanic. Collateral can be split across multiple vaults and ordered intentionally. In liquidation, the minimum ordered set of vaults is selected to restore position health. Smaller vaults can act as sacrificial collateral, protecting larger vaults. If seizure overshoots the precise target, the integration applies a fairness debt repayment or, when appropriate, a fairness payment. Who keeps the vault operating and safe? TBV leverages independent operators to keep the system operational and provide safety backstops. The vault provider is chosen by the depositor. The vault provider claims on the depositor's behalf and challenges malicious claimants for that vault. The depositor can also operate this role themselves. Universal challengers are the protocol-defined fallback set. They can challenge across vaults but cannot claim. Vault keepers are specific to an integrated application. In the Aave v4 deployment, these are arbitrageurs. They can claim and challenge for Aave vaults and handle the redemption weight risk around liquidations. Liquidators are specific to borrowing and lending use cases, such as Aave v4. They repay debt when a position falls below the liquidation threshold. The Security Council is a narrow emergency backstop. It can block invalid claims in rare failure scenarios, but it cannot seize BTC or move funds. TBVs are trustless infrastructure that allows native Bitcoin to function as programmable collateral under predefined redemption and liquidation rules, with Aave v4 as the first vertical deployment. The same vault primitive can also support BTC-backed stablecoins, margin for BTC derivatives markets, provider coverage, and many other applications where native BTC needs to function as programmable collateral. For the full architecture, role breakdown, and integration requirements, contact BD at babylonlabs.io.